Hello, and welcome to the Administering SQL Server 2012 Databases, exam number 70-462, certification course offered by Simplilearn. This is the 8th lesson of the course, and we will introduce you to how you can optimize performance on your SQL servers in this lesson. Let us look at the objectives of this lesson in the next screen. After completing this lesson, you will be able to define benchmarking, demonstrate how to use Resource Governor and PerfMon, describe dynamic management views, explain how to work with SQL Profiler. This section deals with benchmarking and some of the tools that are available to you in an installation of SQL Server to do it. First, let us understand the process of benchmarking. Benchmarking is a process of checking the performance of your SQL Server system against a known set of standards. Performance is based on a huge number of factors. These include common factors like CPU, memory, file system I/O, network speed, how well queries are written or optimized, and many more. You need to use each of these individually as well as in combination to see the real performance and compare it to what you consider should be the ideal. You can view and manage this performance using a number of different tools. There are tools that will allow you to view the current performance, while others will let you change parameters to achieve a particular performance goal if possible. These also let you set up a baseline, one that works under ideal conditions, and see how it performs as well. Let us next learn about Resource Governor. The first tool we're discussing is the Resource Governor. This is a component that is installed with SQL Server and is able to manage workloads within it. How the tool works is to set limits to resources such as CPU and RAM. You then set up workloads, basically how much of the system to use for these different resources, and then assign them to the pool of resources. Since the resources have limits set, both a minimum and a maximum, the Resource Governor ensures that the workload assigned to it doesn't get below or use more than what is assigned. This makes setting up the baseline, as well as performance, much more predictable, as you know exactly the amount of CPU and RAM being used by each SQL Server component or service. The next screen discusses the tool called PerfMon. PerfMon is a common name for the tool called Windows System Performance Monitor. This tool is available in all versions of Windows, whether or not SQL Server is installed. When it is, it adds a number of SQL Server specific parameters, called counters in PerfMon, that can be used. PerfMon allows you to add one or more counters to the view and shows you real-time information about those ones. You can view more than one parameter at a time and mix system counters with SQL Server ones. For instance, you might add the system counters for processor usage and memory, as well as a SQL Server counter for stored procedure execution. Now, if you notice that CPU and stored procedure execution spike together, you realize that there is some optimization required in your SPs. In this demo video, we will benchmark the system using PerfMon and then use Resource Governor to set up a new workload with some limits. For this demo, we are going to create a new resource pool in the Resource Governor. The new pool, called Demo, is set to use a minimum of 10% of CPU and memory and a maximum of 80% for both. We now create new workloads for the pool to define how the resources are utilized. For this pool, we are going to define 3 workloads, one for peak office times, one for during lunch, and another for when the office is closed or off-peak hours. Since we haven't defined how the system will determine what makes up these times, we are going to write a simple function that returns the workload name based on the time on the server. As you can see, this returns the exact name of the workload for different times of the day. We need to modify the setting of the pool to use this function under the classifier function name as shown. Let's now create a new session and check which workload it works on. To do this, we're using a standard query provided by Microsoft to view the running stats. As you can see, the 2 latest sessions are using the lunch workload, since the time is 1:58 p.m., and the classifier function we defined sets this to lunch. We change the time and set it to a few minutes ahead to test whether the workload changes correctly. We are creating a new session at a new time and using it. On running the query again, note that this new session is run under the peak workload, as the resource governor now determines that lunchtime is over and the session requires more resources. In this section, you will take a look at dynamic management views and also learn about the SQL Profiler tool. First, we will learn about dynamic management views. Dynamic management views, or DMVs, are system views. These are very similar to system databases and system stored procedures, but are views that collate information from different system tables to show you a consolidated view of system information. These views query data for different server state information from system tables. You can check server configured values, current values, running states, and performance. There are many different DMVs available, and in categories as in the case of system stored procedures. Using a DMV is very much like using any view or table. Simply query it using a select statement. Most, if not all, DMVs have a prefix of DM in their name. For instance, in an earlier lesson, you looked at a DMV called DB file space usage to view the amount of disk space a particular database was using. The next screen talks about SQL Profiler. The SQL Profiler is another tool that is included by default in an installation of SQL Server. This tool allows you to create and view what are known as trace logs. These trace logs are not the same as the logs for the database. Instead, these first need to be turned on or enabled before they are captured. The trace log captures event traces, that is, the firing and execution of events on the server. Once turned on, the trace log captures everything happening on the server along with metadata such as the type of event, the start and end time, the user, role and service that initiated it, the query that was fired, and more. You can use this trace log to view how queries are performing and then figure out a way to optimize them. Any bottlenecks in your system can be easily found by turning on the trace, running the suspected bunch of queries, and then turning the trace off. Analyzing the log can reveal which query took the maximum time and is probably the bottleneck. In the following demo, we will use a few DMVs to see how they work and the data they return. The first DMV we are using is the OS wait stats. This basically gives us the amount of time, in milliseconds, that tasks have to wait to get executed. As you can see, it tells us the number of tasks in each type, the wait time, and the maximum wait time for each. If we want to see only ones that are for I/O performance, we can add a where clause for those. The next DMV we will see is the OS memory clerks, which returns a list of memory statistics for different operations. In this demo, we are looking at the sum total of all operations. This next query is provided as a standard one by Microsoft to view details of caches for each object on the server and uses two DMVs, OS memory cache counters and clock hands. This last query is also provided by Microsoft. It allows you to see the CPU stats for each query plan that is generated on the server. The following video demonstrates the use of SQL Profiler and the kind of data it captures. SQL Profiler lets you run a trace to see what queries are being fired and how each one is working. The first thing to do is start a new trace and set some of its properties and start the trace. Switch back to SSMS and run a query, maybe using a function or stored procedure you wish to analyze. Go back to the trace and pause or stop it. Note the execution of the command is caught in the profiler as well. In this section, we will take a look at how we can optimize indexes as it increases the overall performance of the server. We will learn about index statistics in the next screen. The first thing to do to understand indexes and how they perform is to look at a value called index statistics. This property tells you how the values in the column are distributed. This distribution is called the index statistics. For instance, this lets you know things like there are 50 rows with the value blue and 23 with silver. The index statistics are important since the query optimizer uses these statistics to generate the query plan we learned about earlier. In all cases, the system generates these statistics automatically. You can, however, view all these statistics that are generated. In some cases, you can also go and generate custom statistics in case you wish to change the way these statistics work. Let us now discuss index fragmentation. Indexes, as you have learned earlier, are created in a B or B+ tree structure. Inserts, updates, and deletes rearrange the leaves in the tree-like structure. Unfortunately, what this does is also create an imbalance in the form of extra leaves on one side or lesser on the other side. This imbalance also leads to unnecessary splits in the index where simple rearrangement could have been enough. This is what is known as index fragmentation. This is very similar to fragmentation that happens on your hard disk. Unfortunately, you cannot defrag your indexes the way that you can do on your hard disk. You can view the level of index fragmentation using a DMV. The more the fragmentation, the lesser the performance of the index. If the fragmentation is too high, you should reorganize the index. This can be done by either rebuilding the index or by dropping and recreating it. You will see how you can view index statistics in this demo video. Let's first take a look at the indices defined for the product table in the sample database. As you can see, there are 4 indices created. When you open the statistics, you see that there are 4 sets of statistics too, one for each index. Before we create an index, let us see some auto-generated ones by first writing a simple query. Since this query didn't really need to perform any filtering, there is no new statistic created. When we add a filter on a new column, say list price here, and run it, the system automatically generates a new statistic. We can open the statistic to view what it looks like. We now create a new index for the color column. This automatically creates a new statistic for that index as well. We can view the values that are present and their distribution. If there have been changes in the values, you can update these statistics as well. This video will demonstrate how to rebuild the index. We simply open the same products table as in the last demo and open the Indices node. Right-click the index we need to rebuild, the one we created for color, and select Rebuild. Clicking OK rebuilds and optimizes the index. Here is a quick recap of what we have learned in this lesson. Benchmarking is the process of checking the performance of your SQL Server system against a known set of standards. Resource Governor is used to limit resources, and PerfMon is used to view usage. Dynamic Management Views, or DMVs, are system views. These are very similar to system databases. SQL Profiler allows you to create and view trace logs. This concludes the lesson, Optimizing Servers. The next lesson focuses on troubleshooting errors in SQL Server.